somewhere on the Zaporizhia axis, autumn 2023. A Ukrainian designated marksman is lying in a position he has occupied for 3 hours. His rifle is over 60 years old. The same basic design that Soviet engineers finalized in 1963. The same gas-operated action. The same 7.62 x 54 mm rimmed cartridge that has been in continuous military service since 1891. The scope on top is a PSO-1, a fixed 4-power optic whose reticle contains a stadiometric rangefinder calibrated to the width of a standing human body, a bullet drop compensator, and windage hashes marked in milliradians by the standards of what Ukrainian snipers are also using in 2023, Barrett M10 7A1 anti-material rifles, Barrett MARD systems in .338 Lapua Magnum, domestically produced UAR 10 precision rifles. This weapon belongs to another era entirely. He keeps using it. He prefers it. When asked why, the answer will be some version of the same things SVD operators have been saying for half a century in Afghanistan, in Chechnya, in the Donbass, and now across the full-scale invasion front. It is light enough to carry all day, reliable enough to fire when dirty, and accurate enough to kill at the ranges where most engagements actually happen. The newer Western rifles are more accurate at 1,000 meters, but most targets are not at 1,000 meters. This is the SVD Dragunov, not simply a sniper rifle and not simply a relic. It is a design that solved a specific problem so well that 60 years of wars have yet to produce a more widely used answer to it. The problem it solved began with a doctrinal crisis that the Soviet military identified in the late 1950s, and that NATO would spend 30 more years failing to recognize it had. The issue was the assault rifle's fundamental compromise. By the mid-1950s, the AK-47 had replaced the rifle and submachine gun combination in Soviet infantry squads. This was a genuine improvement. The AK's 7.62 x 39 mm intermediate cartridge was effective out to about 300 meters, controllable in automatic fire, light enough to carry with large quantities of ammunition, and in Kalashnikov's gas-operated rotating bolt design, reliable to a degree that no previous Soviet weapon had approached. But the Soviet military planners noticed something that the tactical advantages obscured. The Mosin Nagant bolt-action rifle that the AK replaced had been effective to 600 meters and beyond in the hands of a trained shooter. The AK was not. The adoption of intermediate cartridges for the standard infantry rifle had traded long-range capability for volume of fire. At ranges between 400 and 800 meters, a Soviet rifle platoon armed entirely with AKs could not reliably kill individual targets. If a machine gunner, an officer with binoculars, or an anti-tank crew was operating at 600 meters, the platoon's rifles were useless against them. NATO recognized this problem only after watching the Soviets solve it. Western militaries in the late 1950s still believed that genuine precision shooting was the exclusive province of specialized two-man sniper teams. A shooter with a bolt-action rifle, trained for months in fieldcraft, operating independently or semi-independently of the infantry. This doctrine produced weapons of great accuracy. Germany's Heckler and Koch PSG-1, adopted in 1972, could achieve sub-Moa groups, but it produced them in small numbers for specialists, at high cost, and with a training pipeline that took dedicated soldiers out of line units for extended periods. The model assumed that precision fire was a rare requirement served by scarce experts. The Soviet understanding was different. Precision fire at the squad and platoon level was not a rare requirement. It was a continuous one. Every time an enemy section moved, there were individuals at the front of that movement, section leaders, weapons carriers, radio operators, who needed to be killed at the ranges where the movement was first observed. Every defended position contained personnel who would be visible, briefly, at distances where a standing human was too small to guarantee a hit with an AK on full automatic, but large enough for a trained shot to hit with a careful squeeze of a trigger. What the Soviet military wanted was not a dedicated sniper as a separate specialist. It was a marksman embedded in every rifle platoon, carrying a weapon capable of precise semi-automatic fire at those ranges, moving with the platoon and supporting it in every engagement rather than operating separately. This required a weapon that did not yet exist. The man who built it was born in Izhevsk on February 20th, 1920, into a family that had made weapons for 3 generations. Both Yevgeny Fyodorovich Dragunov's grandfather and great-grandfather had been gunsmiths, and he grew up in the city that was, and remains, the heart of Russia's small arms industry. He entered the Izhevsk Industrial College in 1934 after completing 7 years of general schooling, training as a technologist for the arms factory. And by the time he was drafted into the Red Army in 1939, he was already a qualified shooting instructor, a level of marksmanship expertise far above the conscript average. During the war from 1941, he worked as a senior armorer, maintaining Soviet weapons and examining captured German and Japanese pieces to understand their engineering solutions. He came back from the war not just as a mechanic of firearms, but as someone who had handled everything the mid-20th century had produced in this category. After 1945, Dragunov returned to Izhevsk and joined the Arms Design Bureau, not as a military weapons designer, but as a sporting and competition rifle engineer. Through the late 1940s and 1950s, he worked on precision target rifles, weapons where mechanical accuracy was not a secondary consideration, but the primary one. His S-49 sporting rifle, the first Soviet target rifle designed for competition at all levels, brought the Soviet Union its first world record at international competitions in Bulgaria in September 1950. Later, his biathlon target rifle, the BI-59, developed with colleague A.S. Shesterakov, was in Soviet athletes' hands at the 1960 Winter Olympics in Squaw Valley and contributed to their performance there. He was, in the language of Western gunsmithing, a precision rifleman. Accuracy was not a design criterion he was willing to sacrifice easily. This matters for understanding the SVD, because when the Soviet military announced its competition for a new semi-automatic marksman's rifle in 1958, the specifications it set were not those of a combat pragmatist willing to accept mediocrity. The competing designers, Sergei Simonov, designer of the SKS carbine and among the most respected weapons engineers in Soviet history, Alexander Konstantinov from the Kovrov Design Bureau, and Dragunov from Izhevsk, were given requirements that demanded genuine precision from a gas-operated semi-automatic rifle, something the Western weapons world broadly believed was either impossible to achieve or required an engineering effort far beyond what mass military production could support. Simonov's prototype was rejected in April 1960. His design, while drawing on extensive experience, did not achieve the accuracy standard. Konstantinov's 2B10 prototype went further in the trials. It was simpler to produce and cheaper, genuine advantages in Soviet procurement, but field testing across a wide range of environmental conditions showed it fell short of Dragunov's entry in accuracy, durability, and reliability under extreme conditions. In early 1962, the final comparative trials concluded, and Dragunov's proposal was accepted. On July 3, 1963, the weapon was formally adopted by the armed forces of the Soviet Union as the 7.62 mm Snaperskaya Vintovka Dragunova, the SVD. An initial pre-production batch of 200 rifles was assembled for evaluation, and from 1964, serial production began at Izmash, the Izhevsk machine building plant. For the development and production launch, Dragunov was awarded the Lenin Prize in 1964, the Soviet Union's highest honor for scientific and creative achievement. The design Dragunov produced is one of the few semi-automatic precision rifles in history where the mechanical decisions and the doctrinal requirements align completely. Understanding the weapon properly requires understanding that it is not, in the Western sense of the word, a sniper rifle. It is a designated marksman rifle, a weapon category the SVD effectively invented before Western militaries had a name for it. The distinction is not semantic. A sniper rifle is optimized for maximum possible accuracy at the longest possible range, deployed by a specialist who may spend days reaching a single position, shoot once, and withdraw. A designated marksman rifle is optimized for reliable precision fire at combat-relevant ranges, deployed by a soldier who is also expected to assault buildings, ride in armored vehicles, and participate in the full range of infantry activities. The requirements produce different weapons. The SVD's action is a short-stroke gas piston system with a two-position gas regulator and a rotating bolt. With 3 locking lugs, the choice of short-stroke rather than the AK's long-stroke piston was deliberate and consequential. In a long-stroke system, the AK being the definitive example, the gas piston and bolt carrier are physically connected, and the heavier combined mass moves rearward together when the gas port fires. This movement is energetic, reliable even with fouled gas ports and degraded ammunition, and essentially immune to the variations in gas pressure that different ammunition produces. It is why the AK works when an SVD might not. But that moving mass is disruptive to accuracy. It is in motion before the bullet has left the barrel, its momentum pulling the rifle off target fractionally before the shot is complete. For a weapon designed for volume of fire, this is an acceptable trade. For a weapon designed for precision, it is not. Dragunov's short-stroke system uses a separate lighter piston that travels only a short distance, transfers its energy to the bolt carrier, and then stops. The carrier and bolt continue rearward under their own momentum. The total moving mass is lower, the disruption to barrel harmonics is reduced, and the rifle can be made to print more consistent groups. The bolt's 3 locking lugs, versus the AK's 2, provide more repeatable lockup geometry at the point of firing, contributing another small increment of accuracy that compounds across a 10-shot group. The receiver is milled from steel rather than stamped, more expensive to produce, more time-consuming, but resulting in a stiffer, more dimensionally consistent platform. Every one of these decisions carries a cost, and that cost is the reason the SVD is more expensive to build than an AK and requires more careful maintenance to operate at its best. Dragunov accepted those costs because he had been given a specification that required them. The barrel is 620 millimeters long, necessary to extract the full velocity potential from the 7.6 2x5 4 millimeters R cartridge, chrome lined against corrosion and wear, and deliberately left, with a thin profile to keep overall weight manageable. The overall length reaches 1,225 millimeters, nearly the height of a tall person, and the complete weapon with the PSO, 1 scope, and an empty magazine weighs 4.3 kilograms. That weight figure deserves emphasis. The British L96A1 bolt-action sniper rifle, adopted in 1983, weighs 6.5 kilograms. The American M24 sniper weapon system, adopted in 1988, weighs 5.5 kilograms. The Barrett M107A1, which Ukrainian forces also use in the current conflict, weighs 12.9 kilograms. The SVD is lighter than all of them. A soldier who carries it all day, alongside full combat load, ammunition, body armor, and water notices the difference in a way that statistics cannot capture. The stock deserves specific mention because it addresses a constraint that defeated many Western attempts to design semi-automatic precision rifles during the same era. The laminated wood thumbhole stock, which became one of the SVD's most visually distinctive features, is free-floating from the action rather than bearing against the barrel at any point. Barrel harmonics, the oscillation pattern a barrel executes as the gas pressure wave travels down it, are among the most significant contributors to shot-to-shot variation in a precision rifle. A barrel that contacts the stock transfers those vibrations into the stock and back into the barrel in a pattern that changes with temperature, humidity, wear, and the shooter's grip pressure. A free-floating barrel experiences its harmonics unmodified by stock contact, The SVD's designers specified free floating as a deliberate accuracy choice. The Silencer Co. Technical analysis of the SVD design notes this directly, observing that the barrel having no contact with the forestock means that using a bipod or rest will affect the harmonics, a limitation that marks the rifle's precision. As dependent on handheld shooting technique rather than supported position, but a consequence of a design priority that was correct for its doctrinal role. The scope that accompanied the SVD from the beginning was, in the Dragunov.net assessment, arguably the most sophisticated sniper scope ever designed at the time of its introduction in 1963. This claim stands up to scrutiny. The PSO-1, manufactured by the Novosibirsk instrument-making factory, is a 4x24mm fixed-power optic, sealed and nitrogen-filled to prevent fogging, with a temperature operating range from -50 to +50 degrees Celsius. Its reticle contains 3 separate functional systems simultaneously available to the shooter. A stadiometric rangefinder, calibrated to the height of a 1.7-meter standing target, visible on the left side of the field of view, and providing range estimates from 200 to 1,000 meters by comparison against the target's apparent height. A bullet drop compensating chevron for the 7.62 x 54mm, our cartridge's trajectory out to the same range, and 10 horizontal hash marks spaced at 1 milliradian intervals for windage and lateral lead corrections on moving targets. What this means in practical use is that a trained SVD operator can, without touching the elevation or windage turrets, estimate target distance using the rangefinder, apply the corresponding BDC chevron, apply windage compensation from the hash marks, and engage a moving target, all in the time it takes to acquire the target in the scope, which is designed for rapid acquisition at 4 times magnification rather than for the deliberate, eye-strain-inducing study of a high-power scope. Western sniper scopes of the same era typically offered 10 times magnification, better resolving power at long range, and superior discrimination of fine detail. They required turret adjustments between shots for range changes. They were better instruments for a specialist who knew the range in advance and had time to adjust. They were inferior instruments for a platoon marksman who needed to engage a target of unknown range that had just appeared and would disappear in seconds. The PSO-1 also incorporated a feature that the Dragunov.net scope documentation describes as one of its most unusual at the time of introduction: an infrared detector. A small photoluminescent screen inside the scope body glowed when exposed to infrared light, allowing the SVD operator to detect first-generation Soviet bloc and Western night vision devices that illuminated targets with infrared spotlights. In the context of the Cold War confrontation for which the weapon was designed, this was genuinely useful intelligence. A first-generation NVG user who illuminated a target was simultaneously revealing his own position to any SVD operator aware of the capability. The modern PSO-1M2 variant removes this feature, the infrared filter rendered obsolete by the universal adoption of passive image intensification night vision that requires no infrared illumination. The cartridge the SVD fires is itself a character in this story. The 7.62 x 54mm rimmed round was designed for the Mosin Nagant rifle in 1891, making it the longest-serving military cartridge in the world. By the time the SVD adopted it in 1963, it had already been in continuous service for 72 years. The Soviet decision to chamber the SVD in this cartridge rather than developing something new was not conservatism. It was logistics. The 7.62 x 54mm R was already in production for the PKM machine gun, for armored vehicle mounts, for aircraft applications. Every Soviet motorized rifle unit already had stocks of it. An SVD, marksman drawing from the same ammunition supply as the unit's machine gunner, required no separate logistics stream, and in a Soviet force designed for high-tempo offensive operations over enormous distances, logistical simplicity was a genuine operational advantage. The sniper-specific ammunition developed for the SVD, however, was anything but off the shelf. The 7N1 cartridge, developed in 1966 by V.M. Sabelnikov, P.P. Sazonov, and V.M. Dvoryanov, specifically for the SVD, used match-grade extruded powder instead of the coarser ball propellant in standard rounds, a 9.8-gram boat-tailed full-metal jacket projectile with an internal air pocket, a steel core, and a lead knocker in the base. The lead knocker was a Soviet terminal ballistics innovation. On impact, the deformation sequence causes the jacket to split and the lead mass to drive forward through the body with higher tissue disruption than a comparable standard round. The military wiki account of the 7N1 describes its ballistic coefficient as approximately 0.411 on the G1 scale, significantly better than the standard L bullet's 0.338. Loaded with 7N1, the SVD was a categorically more accurate weapon than with standard machine gun ammunition, and the Soviet doctrine of issuing dedicated sniper rounds separately from general supply specifically recognized this. Before we get to what the SVD has actually done across 60 years of warfare, and specifically what it is still doing in Ukraine, if this depth of analysis is what keeps you coming back to this channel, subscribe. It costs nothing, takes one click, and makes it possible to keep producing content at this level. Let's talk about what the Dragunov did when it actually went to war. The SVD's first significant combat exposure came in Vietnam, where North Vietnamese army units received the rifle as Soviet military aid beginning around 1967. American soldiers encountered it as a weapon they did not immediately recognize. Longer and slimmer than any rifle in the NVA's standard infantry. Accurate at ranges where the M16 was effective in volume but not in precision. The SVD's appearance in Vietnam preceded NATO military's formal development of the designated marksman role by more than 20 years. The American experience of being outranged by individual NVA marksmen using Soviet-supplied precision semi-automatics was one of the factors that eventually drove the United States toward the M21 system and, eventually, the M110 SAS semi-automatic precision platforms in 7.62 x 51 mm NATO that addressed precisely the squad-level precision gap the SVD had been built to fill. The Soviet-Afghan War from 1979 to 1989 placed the SVD in conditions it was not entirely designed for and revealed both its genuine strengths and its specific limitations. The mountainous terrain of Afghanistan stretched engagement ranges significantly beyond the 300 to 600 meter zone, where Soviet doctrine anticipated most combat. Mujahideen fighters using cover at 800 and 900 meters were often beyond the SVD's reliable effective range with standard ammunition, and Soviet snipers found themselves outranged in terrain where elevation multiplied the reach advantage of every weapon. The Safar-Publishing.com analysis of the SVD in Afghanistan, drawing on Soviet veteran accounts, notes that the rifle performed reliably in the dusty mountain environment but required significant maintenance attention. The higher precision tolerances that made it more accurate than an AK also made its gas system more sensitive to the fine, penetrating dust of the Afghan highlands. A former combatant quoted in the Russia Beyond account of the SVD describes his Chechnya experience with the rifle. In all his time there, he never heard anyone speak badly of the SVD, and a trained marksman could pick off an enemy on a hillside 700 meters away. The Afghan terrain pushed beyond what Soviet doctrine intended the weapon for. The Chechen terrain, urban rubble, corridors, stairwells, ranges under 500 meters, returned it to exactly the environment it was designed to dominate. The two Chechen wars, 1994 to 1996 and 1999 to 2009, produced the SVD's most extensively documented close-range performance record. The collapse of the Soviet Union had put enormous quantities of SVDs into the hands of Chechen fighters, many of them former Soviet army soldiers who had trained on the rifle and knew its capabilities precisely. Russian federal forces found themselves in sniper duels, where both sides were armed with Dragunovs, which the national interest analysis of Russian sniper doctrine describes with an observation that captures the weapon's strange endurance. Russian troops faced Chechen snipers, often ex-Russian army snipers, armed with Dragunovs during the war from 1999 to 2009. The same weapon, on both sides of the same conflict, 60 years after its design was finalized. The US military also encountered SVDs in Iraq, where Chechen mercenary snipers employed on behalf of various Iraqi factions demonstrated the shooting techniques that the Soviet military had spent 30 years codifying. The SVD's proliferation tells its own story. The Soviet Union shared the design with Warsaw Pact allies and was notably selective about how it did so. Romania's refusal to participate in the Warsaw Pact invasion of Czechoslovakia in 1968 resulted in Moscow declining to share the SVD's technical specifications with Romania, which then developed its own PSL, a weapon that uses the same cartridge and superficially resembles the SVD, but is mechanically entirely different. Built on a scaled-up RPK platform with the AK's long-stroke piston action, the PSL's accuracy is inferior to the SVD's, a difference that Romanian-origin weapons in conflicts from Yugoslavia to Iraq allowed Western analysts to document by comparison. The SilenceEcho.com technical analysis of the SVD makes the distinction precisely. The PSL is commonly confused with the SVD, but is a completely different rifle. The mechanical signature of the AK action that drives it is measurable in the shot group. China reversed engineered, captured SVDs during the Sino-Vietnamese War of 1979 to produce the Type 79 and Type 85 clones, which the Global Military.net SVD analysis notes was subsequently offered for export by Norinco. Poland produced the SWDM, a modernized variant with a heavier barrel, bipod, and variable power 6x42 scope. Iraq produced the Al-Qadasi, a local variant with non-interchangeable parts. Bulgaria, Hungary, Egypt, the design propagated through every Soviet client state and several that were not formally aligned. In the 1945 assessment of the SVD's global service record, the rifle has seen documented use in at least 27 distinct conflicts from the Vietnam War to the current Russian invasion of Ukraine. The MilitaryFactory.com listing of the SVD's conflict record spans from 1955 to 1975 through the present day without a gap. There has been no period in the past 60 years when a Dragunov was not being fired in an active conflict somewhere in the world. Which brings us to Ukraine in 2022, and the question the title of this script poses: why, in a conflict where Ukrainian forces have access to Barrett anti-material rifles, MRAD systems in .338 Lapua Magnum, and domestically produced UAR-10 precision platforms, are SVDs still in Ukrainian hands and still being used? The Wikipedia article on the SVD states it directly, drawing on McNabb's 2023 technical analysis. In Ukrainian service, the SVD was largely replaced in the sniping role with Western sniper rifles chambered in .338 Lapua Magnum or 7.62 x 51 mm NATO and anti-material rifles such as the Barrett M107A1. The domestically produced UAR-10 is also replacing the SVD in Ukrainian military and law enforcement units. But according to McNabb, the SVD remains in service with Ukrainian forces in the designated marksman rifle role. That last sentence contains the entire answer. The Western .338 rifles that Ukraine has received are superior instruments for specialist snipers engaging targets at 1,000 meters and beyond. They are heavier, more expensive, chambered in ammunition that requires separate supply, and optimized for the kind of deliberate, long-range engagement that a trained specialist conducts from a prepared hide. They are not appropriate weapons for a platoon-level designated marksman who needs to engage targets of opportunity at 400 meters during an assault, then transition to CQB in a tree line, then provide overwatch during a withdrawal. The SVD is appropriate for exactly that role. It weighs 4.3 kilograms, It feeds from a 10-round detachable box magazine that can be changed in seconds. The PS-01 scope detaches from its Warsaw-packed side rail without losing zero, allowing iron sights to be used in the instant when the scope is simply too much. The bayonet lug? Yes, the SVD has a bayonet lug, reflects Soviet doctrine's expectation that the platoon marksman would sometimes be in a trench. The national interest analysis of Russia's own position regarding the SVD articulates the same dynamic from the other side of the front line. Russia's Kalashnikov concern announced in late 2024 that it was increasing SVD production several times over at the request of defense customers for the ongoing war in Ukraine. This, despite having just formally adopted the SVTH Chukevin rifle as the SVT's replacement in 2023. The Militarny.com account of this announcement carries a quote from the SVJ's designer that reveals the precise nature of the SVD's durability. The Chukevin is superior to the SVJ primarily in ergonomics and modularity. Picatinny rails for modern optics, folding adjustable stock, better interface for current accessories, but the cartridge is the same, meaning the penetration and range have not changed. The SVCH is 25 to 30% more accurate than the SVD. It can engage targets to 1,000 meters versus the SVD's reliable 800. These are genuine improvements. They are also, in the conditions of trench warfare across the Ukrainian steppe, where the median engagement range is well under 500 meters, improvements whose practical effect is smaller than their technical description suggests. The accuracy comparison that the national interest article draws between the SVD and the M24 SWS is worth stating precisely. The M24 with military-grade sniper ammunition achieves approximately 0.6 MOA. The SVD with 7N1 sniper ammunition achieves approximately 1.04 MOA extreme vertical spread, degraded by the 1970s barrel twist, changed to approximately 1.24 MOA, and with standard ammunition typically 1.5 to 2.5 MOA. These are real differences. At 800 meters, 0.6 MOA is a group 13 centimeters wide. 1.5 MOA is 33 centimeters wide. Against a torso-sized target, both are capable of first-shot hits in the hands of a trained shooter. Absent wind and mirage, at 400 meters, the numbers halve. At 300 meters, the SVD's group is 13 centimeters, against a target whose vital zone is roughly 30 centimeters wide. The accuracy gap that appears decisive in long-range precision shooting becomes operationally irrelevant at the ranges where designated marksmen most often work. The SVD was designed for that working distance. Dragunov, who spent his formative career designing precision rifles for Olympic-level target shooting, an activity conducted at known ranges from stable positions with perfect ammunition, understood the difference between mechanical accuracy potential and combat effectiveness. His biathlon target rifle helped Soviet athletes win medals in Squaw Valley in 1960. His military rifle was designed not for the range, but for the platoon. The two requirements demanded different weapons, and he made both. Yevgeny Dragunov died in Izhevsk on August 4, 1991. 4 months before the Soviet Union ceased to exist. He did not live to see his rifle in Afghanistan become a weapon for Mujahideen fighters to use against Soviet soldiers, or to see it in Chechnya in the hands of the men who had been trained to use it, and then change sides, or to see it in Ukraine on both sides of a front line, where the soldiers of 2 former Soviet republics were shooting at each other with weapons their grandfather's army had put into service. The Kalashnikov concern, which makes his rifle today, named a street after him in Izhevsk in 1992 and opened a park in his name in 2019. His youngest son, Alexei, is also a weapons designer who contributed to the PP Bison submachine gun. His legacy runs through the family, as it always had. 3 generations of gunsmiths, followed by a 4th. The rifle itself is still in production. The Kalashnikov concern announced in 2024 that it was increasing SVD output several times over. The UAR-10 is replacing some Ukrainian SVDs. The SVCH is replacing some Russian ones. Neither replacement is happening fast enough to remove the SVD from the front lines of the largest land war in Europe since 1945. It will still be there in 5 years, almost certainly in 10. The title of this video calls the SVD ancient. That is accurate by any calendar measure. The design was finalized in 1963. The cartridge it fires entered service in 1891. The scope concept was designed for first-generation night vision technology that no military has fielded since the 1980s. By the standards of contemporary precision rifle design, modular chassis systems, first focal plane variable power scopes, suppressors, sub-MOA semi-automatics, it is antiquated in almost every respect. It is also, at the ranges where most designated marksmen actually work, on the day they actually carry it, still more than sufficient. And that is a different kind of ancient. Not obsolete, but settled. A design that answered its questions so completely that 60 years of better options have not yet managed to replace it.